Today I want to talk about one of the most important tools that precious metals collectors and dealers can own, the Sigma Metalytics. If you spent any time in a coin shop, you've probably seen one of these machines. A dealer places the coin on a sensor, waits for a second, and the machine either passes or fails the coin. But have you ever stopped to ask yourself, how does it actually work? How can this machine tell the difference between silver, gold, copper, platinum, or a counterfeit coin without scratching it, drilling into it, or removing it from the holder? Well, today we're going to answer that question. We'll talk about the science behind the Sigma, why professional dealers trust it, and where its limitations are, and why understanding this tool is just as important as owning one. Good morning, it's today again. Welcome back to Joseph's Reserves. I'm Joseph, and I store 20% of my income in the form of rare coins and precious metals. Today, we're going to be talking about the Sigma Metalytics Precious Metals Verifier. But before we do that, I want to say congratulations to Costa Koivunen for getting to my comment section first in my last video. Thank you so much for the support. Before we can understand the Sigma, let's look at other ways collectors and dealers authenticate precious metals. The first is the acid test. By dropping a specific acid on a coin, you can tell a lot about the composition of the metal, but it's destructive, and it requires making contact with the surface, and that's simply not something you want to do to collectible coins. The next is a magnet. Precious metals simply are not magnetic, but it's also true for other alloys like copper. So a magnet is a useful tool. It can eliminate obvious counterfeits, but a non-magnetic result doesn't automatically mean that the coin is genuine. Another way a magnet can be used is by sliding it down the edge or face of a coin, and you'll see that the magnet will fall slowly. However, in pure copper, copper is conductive enough that you get a similar result, and we'll get more into that later. Another test is a specific gravity test. In this test, you'll dangle a coin in water and get a weight and compare that to its dry weight to calculate its density. This test involves handling the coin in water, which many collectors prefer to avoid with higher end pieces. We also have the ping test, which would involve pinching the center of the coin and smacking it so that we could hear its resonance. And while this is a pretty good test, it relies on a quiet environment and a well-trained ear. All of these tests, as well as the actual weight and measurements of the coin itself, give us a piece of the puzzle, and the Sigma gives us another piece. The beautiful part of the Sigma is that it does it quickly without damaging or even touching the coin. So what is the Sigma actually looking at? The Sigma is not identifying the coin for you. It's not that you just place it on the sensor and it tells you that's a gold eagle or a gold Krugerrand or a silver maple leaf. It doesn't know the date or the mint mark. It doesn't know whether or not the coin is $30 or $30,000. Instead, it's measuring how the metal itself responds to an electromagnetic field. And that is the entire secret. Inside of this machine is a sensor that generates a very small alternating electromagnetic field. When that field encounters a conductive metal, something happens. The metal responds. Tiny electrical currents called eddy currents are induced within the metal. Those currents in turn generate their own electromagnetic field, and the Sigma measures that response. Different metals respond differently because they have different electrical properties. Silver behaves different than copper, copper behaves differently than gold, and gold behaves different than platinum. Even two different gold alloys can produce very different responses. The Sigma isn't seeing the design or reading the date. It isn't reading the purity stamped on the coin. It's just measuring the physics of the metal. And the physics is much harder to fake than the appearance. And that's one of the reasons this tool becomes so trusted by dealers all around the world. Now let's take this a step further, because this is an example of how fine-tuned this piece of equipment really is. A common assumption is that two coins that are 22 karat should test exactly the same, but that isn't true. If we look at the American Gold Eagle and the South African Gold Krugerrand, they are both 22 karat. However, the remainder of the 8.33% alloy in the American Gold Eagle is split up between copper and silver, and in the South African Gold Krugerrand is entirely copper. Those two different alloys have completely different electrical properties, and so there are two completely different profiles that the Sigma can be used to look at these two different coins. And as you can see, the Krugerrand failed as an authentic coin when looking at it as if it was an eagle, and the eagle failed when looking at it as if it was a Krugerrand. This works because the machine is simply just looking at its electrical profile. Those sensors are sending information to a computer that probably has some sort of data chart and just comparing it to an expected results. So now that we have an understanding of how this Sigma Metalytics actually works, I want to talk about the limitations of this Sigma. Not because they're a weakness, but because understanding the limitations is part of understanding the tool. No scientific instrument is perfect. Every instrument measures something specific. A scale measures weight, calipers measure a dimension, and the Sigma measures electrical response of the metal. But that's it. It doesn't grade, it doesn't authenticate dates, it doesn't identify mint marks, it doesn't tell you if a coin has been cleaned, it doesn't recognize counterfeit die pairings, and it doesn't replace good judgment. What it does do incredibly well is answer one question. Does this metal behave the way I would expect this alloy to behave? But every tool acts within set parameters. That means if there was something that came close to this electrical response, it could possibly pass even if it is not the correct alloy. Here we just saw 3 and now a 4th coin that passed on this Sigma Metalytics as 3 or 4 nines silver. This one is a 3-9 silver, but if you're familiar with Australian products, they changed to a 4-9s. So let me show you what this actually looks like under the 4-9s profile. Right here, we could see that it fails this 4-9s profile, and I'll go ahead and get a close-up of the 3-9s so we could see that that's actually what we're looking at here. So yes, there is a difference electrically between 3-9s and 4-9s, and the Metalytics is specific enough to catch that difference. But there's actually something different going on here, and with this next test, I'm going to show you exactly what it is. But don't worry when you see the next thing I'm about to show you, there are ways to figure out what's actually happening. So here I'm going to be testing for 3-9 silver and actually place a 1 ounce copper round on the Sigma. So let's see what it does. Many people know that silver is the most conductive material on the planet, and copper is a close second. And here you can see that pure copper actually comes within the range of a 3-9s silver product. So if that's the case, couldn't I simply just plate copper with silver and it'll pass the Metalytics? And actually, yes, that's exactly what it is. If we look at this kookaburra here that I was testing, that is exactly what happened. So what I'm going to do is stop looking at this pass-fail, and I'm going to read the actual electrical data. We're going to look at resistance. So here I can have it display the resistance, and we can see that the number actually falls at the 1.79 range. When I choose a silver product, we see 1.62. Another silver product, it'll all end up being in this 1.6 area. So here even this 4-9 silver is 1.60. When I get to the kookaburra, we're going to see again 1.7. There it is, 1.74. So we can see that something isn't quite right with this silver quote-unquote kookaburra. To me, that's enough to completely discount this as a real coin, but if you need a little bit more testing, another thing I like to do is testing it with other profiles of high purity silver. Here we have Britannia silver, which is 95.8% silver, or rounded to 96%, and as you can see, the American Silver Eagle is outside of that pass-fail box. We can test other silver and you'll see the same, but when it comes to this kookaburra, which is actually just silver-plated copper, and the pure copper round, we can see that it passes, and the electrical profile is close enough in both the 3-9s fine and 96% alloy test. Clearly something is wrong, and in a shop with an XRF machine, they could even take it over to the XRF and completely verify that this is silver-plated copper. So when people ask me, do you trust the Sigma? My answer is yes, absolutely. Not because I believe it's magic, not because I think it can never be fooled, but I trust it because I understand what it's actually measuring. It's measuring real physical properties that are incredibly difficult and nearly impossible to counterfeit. And that gives me confidence. And as for this Australian kookaburra, don't worry, I didn't just find out it's fake. It was known to be fake before I even got it. I actually got it from Silver Serpents, who was doing a giveaway, and the winner of the giveaway was whoever could pick out this fake from a pile of real coins. Of course, I didn't know that it was fake because looking at it alone, you could tell it's a really, really good counterfeit. However, with a really solid guess, I was able to win this giveaway. So if you haven't checked out Silver Serpents, definitely go check out his channel. He does some really good work over there. But overall, if you are a collector, I hope today's video helps you understand why so many dealers rely on the Sigma Metalytics. It's one of the fastest, safest, most effective ways to gain confidence in the metal that you're buying and selling. And if you're considering purchasing one or owning one for your collection, I hope you now understand that you're not buying a magic box. You're buying a scientific instrument. And like any instrument, it's most valuable when you understand what you're measuring. And if you're a dealer, I hope this gives you a little bit of further confidence with the Sigma and gives you a better way to explain the Sigma to your customers instead of just saying, yeah, this machine says it's real or not. In everything I do, I try to educate as much as I can, so saying something more like, this machine measures the electrical properties of the metal and compares that response to an expected range for this alloy. I think that's much more accurate and much more powerful if you explain what the technology is actually doing. Because in this business, trust doesn't come from one machine. It comes from knowledge, and understanding the Sigma will help you dramatically. So if you like this video, make sure to give it a thumbs up. Go down into the comments section to start or continue a conversation. Subscribe if you haven't already, and share the video with someone you think may enjoy it. And to my long-term subscribers, thank you so much for your continual support. Make sure you go to josephsreserves.com to check out my merchandise, coffee mugs, zip-up bags, and the It's Today Again coffee. But most of all, thank you so much for watching. And just remember, every ounce adds up, so no matter how small, just keep stacking.